Take a look at a world map, the kind you probably had on your classroom wall. Your eyes might drift to the top, to a massive sprawling landmass of ice and snow. This is Greenland. Now look down towards the equator, you'll see Africa, a vast and diverse continent. On this map, Greenland looks enormous, almost as big as Africa itself. But what if I told you that your eyes and the map are deceiving you? What if the reality is something far more dramatic, something that challenges what you thought you knew about the planet we call home? The truth is, Africa is not just a little bigger than Greenland. It's not twice as big, or even 5 times as big. The continent of Africa is a staggering 14 times larger than Greenland. This isn't just a small error, it's a colossal distortion. You could fit the entire United States, China, India, Japan, and most of Europe inside Africa, with room to spare. Yet, on the maps most of us grew up with, this incredible size is shrunk, while land masses in the northern hemisphere are ballooned to epic proportions. Greenland, in reality, is about the size of Algeria or the Democratic Republic of Congo, just one of many large nations within Africa. This single startling fact opens up a universe of questions. Why are our maps so wrong? How can something as fundamental as the size of continents be so misrepresented? The answer lies in the difficult, almost impossible challenge of taking a round planet and squashing it flat. The map you're picturing is most likely the Mercator projection. It has become the default mental image of our world. We see it in textbooks, on news reports, and as the background for countless websites. Its familiar shapes have been etched into our collective consciousness since childhood, but this familiarity has come at a cost. The Mercator map stretches and pulls at the globe, especially near the poles. It's like trying to peel an orange and lay the peel perfectly flat without any tearing or wrinkling. The further you get from the orange's equator, the more the peel has to stretch to fill the corners of a rectangle. This stretching effect is what makes Greenland look like a giant, and Africa seem comparatively modest. This distortion isn't just limited to Greenland. Look at Alaska on a Mercator map. It appears larger than Mexico. In reality, Mexico is substantially bigger. Scandinavia looks vast, but India, which appears smaller, is actually 3 times its size. Russia, while enormous, is not the globe-spanning behemoth the Mercator makes it out to be. Its size is exaggerated by a huge margin. We live on a sphere, a beautiful 3-dimensional orb hurtling through space, but for centuries, our primary tool for understanding its surface has been a 2-dimensional lie. A useful lie perhaps for certain purposes, but a lie nonetheless. And this lie has consequences, shaping how we perceive the importance and power of different parts of our world. So, if this map is so wrong, who made it, and why? To find the answer, we have to travel back in time, back to the Age of Discovery. The year is 1569. A Flemish cartographer named Gerardus Mercator creates a new map of the world. But he wasn't making it for school children. He wasn't even making it for geographers to study the relative sizes of continents. Mercator had a very specific audience in mind: the sailors and navigators who were braving the treacherous open oceans. In the 16th century, crossing an ocean was one of the most dangerous things a person could do. Getting lost meant almost certain death. Sailors needed a new kind of map, a tool that could help them chart a straight course across the vast, empty sea. Mercator's genius was in creating a map where lines of constant bearing, known as rhumb lines, were straight. This was a game-changer for navigation. A ship's captain could draw a straight line from their starting point, say, Lisbon, to their destination, like the Caribbean, and know the exact compass bearing to follow. As long as they kept their ship pointed in that direction, they would eventually arrive. The map preserved angles perfectly. For a sailor, this was everything. The convenience of this navigational trick was so profound that the distortion of land sizes was seen as a small, acceptable price to pay. The map wasn't meant to show you what the world looked like. It was designed to show you how to get across it. The mathematical trick behind this was to make the lines of latitude, the horizontal lines, parallel, just like the lines of longitude. On a globe, lines of longitude converge at the poles, like segments of an orange. By forcing them into a rectangular grid, Mercator had to stretch the space between the lines of latitude as they moved away from the equator. This stretching is what warps the size of everything. Areas near the equator, like Central Africa and South America, are represented fairly accurately in size, but as you move north or south, the stretching becomes more and more extreme. It's a clever solution to a very specific navigational problem. The irony is that a map designed for a specialized life-or-death purpose became our standard picture of the world. It's like using a specialized wrench, designed for a single type of bolt on a spaceship, to build an entire house. The tool is excellent for its original job but wildly inappropriate for general use. The Mercator projection sacrifices the accuracy of area to preserve the accuracy of angles. For a sea captain, that was a brilliant trade-off. For a student trying to understand the relative importance and scale of different cultures and nations, it's a disaster. The sailor's secret tool escaped the confines of the ship's bridge and colonized our minds. How did a 16th century sailor's chart end up on the walls of nearly every 20th century classroom? The transition wasn't immediate, but it was decisive, driven by history, convenience, and a certain worldview. As European powers expanded their colonial empires during the 17th, 18th, and 19th centuries, the Mercator projection became the map of empire. It was the map used to chart trade routes, to delineate colonial territories, and to project power across the globe. Its straight lines were perfect for administrators and military planners, just as they had been for sailors. The map's inherent distortions also happened to align with a Eurocentric perspective of the world. By the 19th and early 20th centuries, when mass education became more common in the Western world, educational materials needed to be produced. Publishers needed a standard world map to print in atlases, textbooks, and on wall charts. The Mercator projection was the most familiar and widely available. Its rectangular shape was easy to print and fit neatly onto a page or a wall. It became the default choice, not through a careful decision about its geographic accuracy, but through momentum and convention. Teachers taught with the map they had learned from, and publishers printed the map that everyone expected to see. The original purpose was forgotten. The distorted image became the accepted reality. This adoption was further cemented by its usefulness as a political and cultural symbol. The Mercator projection, by enlarging Europe and North America, visually reinforced their perceived importance on the world stage, during an era of colonialism and Western dominance. The map didn't just show the world, it presented a version of the world where the northern, predominantly white nations appeared larger and more central. The vast continents of Africa and South America, home to billions of people and rich histories, were visually diminished. This wasn't necessarily a conscious conspiracy, but an unconscious bias that was perpetuated by the continued use of a flawed tool. And so, generations of students, myself included, grew up staring at this distorted view. We learned the names of countries and traced the paths of explorers on a map that quietly fed us a skewed perspective. We absorbed the idea that Greenland was a polar giant, and Africa was a more manageable size. The map became more than just a tool for geography, it became a cultural artifact. It shaped our mental frameworks, our sense of place, and our understanding of the relative scale of human civilizations. The sailor's map had completed its journey, moving from the high seas to the heart of our educational system, embedding its distortions deep within our culture. Maps are more than just paper and ink. They're actually powerful instruments that shape our perception of reality. When we consistently see a map that inflates the size of certain countries and shrinks others, it inevitably influences how we think about them. This isn't just about geography, it's about psychology. The visual prominence of North America and Europe on the Mercator map can, create an unconscious bias, subtly suggesting that these regions are more significant, more powerful, and more important than the lands huddled around the equator. This phenomenon is sometimes called cartographic imperialism, where the map itself reinforces colonial-era power structures. Think about it. Size is often equated with power and importance. In our daily lives, bigger things command more attention. A skyscraper is more imposing than a cottage. A lion is more intimidating than a cat. When we see a map where Russia and Canada seem to occupy a vast portion of the planet's land, while Africa looks comparable in size to Greenland, our brain makes a subconscious judgment. This distorted geography can lead to a distorted worldview. It can make it harder to appreciate the true scale of Africa's diversity, the vastness of its ecosystems, and the immense human and natural resources it holds. It visually understates the significance of the entire global South. This skewed perception has real-world consequences. It can influence political and economic decision-making. If policymakers, journalists, and the public have a flawed mental map of the world, their understanding of global issues, from climate change and resource allocation to demographics and international relations, will also be flawed. When you underestimate the size of a continent, you might also underestimate the magnitude of its problems and the scale of its potential. The Mercator map, in essence, creates a subtle but pervasive misinformation campaign that has been running for centuries, quietly affecting how we relate to our fellow inhabitants on this planet. The effect is so ingrained that seeing a true to-scale map can be a jarring experience. When people are shown an equal area projection for the first time, they're often shocked. Africa suddenly appears immense, as it truly is. South America stretches further than they imagined. Europe shrinks to its correct, more modest proportions. This moment of surprise reveals the power of the map we hold in our minds. It shows that our common-sense understanding of the world was built on a distorted foundation. Challenging the Mercator map is not just an academic exercise, it's an act of reclaiming a more accurate, more equitable perspective of our shared world. The good news is that the Mercator projection is not our only option. Cartographers have been aware of its flaws for centuries and have developed hundreds of other ways to project our spherical Earth onto a flat surface. Each projection is a different compromise, prioritizing certain properties over others. There's really no single perfect flat map, but many offer a much more balanced and honest view of the world than the one most of us are used to. They invite us to see our planet in a new light, challenging the distortions we've come to accept as normal. One of the most famous alternatives is the Gall-Peters projection. The Gall-Peters projection, promoted by Arno Peters in the 1970s, is an equal area map. This means its primary goal is to show the relative sizes of land masses correctly. On a Peters map, Africa and South America are restored to their true immense proportions. Greenland shrinks back to its actual size, no longer rivaling Africa. The trade-off is that this projection heavily distorts the shapes of countries. Continents appear stretched vertically, looking long and skinny, which many people find visually jarring and unfamiliar. While it solves the problem of size, it creates a new problem of shape. It's a powerful statement about area, but perhaps not the best map for general use. For a more balanced approach, many geographers and organizations have turned to compromise projections. The Robinson projection, for example, was an attempt to find a happy medium. It doesn't preserve either area or angles perfectly, but it minimizes distortion across the board. The continent's shapes look more natural and their sizes are less skewed than on the Mercator. The poles are shown as lines rather than points, but the overall effect is visually pleasing. For many years, the National Geographic Society used the Robinson projection as its standard, offering millions of people a more balanced view of the world. A more recent and widely adopted solution is the Winkel triple projection. Created in 1921, it strikes an even better compromise between size, shape, and distance. The distortions of area and angle are smaller than in the Robinson projection. The shapes are less distorted than in the Peters projection, and the size exaggeration of the polar regions is far less severe than in the Mercator. In 1998, the National Geographic Society adopted the Winkel triple as its preferred projection for world maps, recognizing its strength as a general-purpose educational tool. It presents a world that is recognizably spherical, with curved lines of longitude, gently reminding us that we're looking at a flattened globe, not a perfect rectangular grid. So, why does any of this matter? It matters because maps are not just static images. They're the foundation of our spatial understanding of the world. They're the framework upon which we build our knowledge of history, politics, and culture. Using a map that is fundamentally distorted is like trying to build a house on a crooked foundation. Sooner or later the walls will crack, and your entire structure of understanding will be unstable. A more accurate map provides a more stable, more truthful foundation for learning about our planet and the diverse tapestry of humanity that lives upon it. Embracing maps that show the world in its true proportions is an essential step toward a more global and equitable perspective. It helps us decenter a worldview that has for too long been dominated by the visual prominence of the Northern Hemisphere. When we see Africa in its true, vast scale, we can better appreciate its significance. Its 54 countries, its its billions of people, its incredible ecological diversity, and its central role in the human story. It combats the unconscious biases that a Mercator map can instill and fosters a more respectful and accurate understanding of different regions and their place in the world. The debate over map projections is more than a technical argument for cartographers. It's a conversation about how we see ourselves and our relationship to others. It's about questioning the default settings we've inherited and actively choosing a perspective that is more honest and more inclusive. As we navigate an increasingly interconnected world, facing global challenges like climate change, pandemics, and economic inequality, a shared, accurate understanding of our planet is more critical than ever. We can't hope to solve global problems if our basic mental image of the globe is flawed. The universe doesn't care about our maps. Earth is a sphere, governed by the laws of physics, orbiting a star in a vast cosmos. Our planet will continue to be what it is, regardless of how we draw it. But we, as curious and social beings, care deeply. Maps are a reflection of our knowledge and our values. By choosing to use and teach with maps like the Winkle Triple, we're choosing to value truth over tradition. We're choosing to see the world not as a distorted grid of power, but as it is. A beautiful, interconnected, and wonderfully complex whole. And that change in perspective is the first step toward understanding our true place in the cosmos.